Hi, I'm Ludovic Kenny.
And I'm Gino Lepalek. Today we are going to have a great talk about Java RMI. Why did we focus on the Java RMI? Firstly, it is widely used in the Java technology-based distributed application by Java EE servers like Glassfish. Secondly, Java RMI may imply exchanges of sensitive data and remote code execution over the network. Then we know that some security tools like SSL are used by Java RMI, but those tools are not originally implemented for the RMI and do not take its feature into consideration. Therefore, our goal today is to present potential threats and attacks against Java RMI in order to develop a security tool based on our observation.
For that purpose, we set up a virtual lab and we implemented a banking application that we tried to attack. We rapidly focused on the RMI payload. Actually, it's the TCP payload. This is how it looks like. The protocol makes it quite complex, and typically SSL will encrypt the full payload. However, we figure out that sensitive data is only at the end of packet. This end contains variables which are used during the execution of the program. So how can an attacker use this payload? He can extract information. Strings are easily extractable, or we can forge a call to a remote method or return a false result. What can a potential attack look like? Let's assume a bad guy wants to execute a remote method. First, he needs to sniff a packet in order to get the structure of the call. Secondly, he needs to wait until the server responds back. And thirdly, now he has all the information to hijack a TCP connection and to send a false call in order to execute a remote method. So what may you worry about? An attacker can steal information if he can see the communication because everything is in clear text. He cannot directly attack the server or the user because of the randomness of packets. However, if he can learn the structure of the packets and hijack a TCP connection, it can launch an attack. After this observation, we conclude that only the end of packets containing the variable of the application should be secured. I will let Gino speak about the solution that we implemented.
SRMI. SRMI for Secure RMI. SRMI is an encrypted and sign-based tool. In contrast to the use of SSL, SRMI takes place in the application level. So, what are we expecting from this tool? 3 keywords. First, authentication, a two-way authentication based on certificates. Confidentiality, a session key is shared during the authentication process. We then create a secure communication channel and encrypt the sensitive data. That means the parameters and return value of the functions. And integrity, all the Java objects are signed with a private key. So now let's see the performance results. As you can see with the light blue line, which represents the SRMI is much slower than the simple RMI or even the SSL RMI. It's easy to understand why. Indeed, SSL does only encryption where SRMI encrypts and signs. We all know that the signatures are done with a private key, for example using the RSA protocol, and this protocol is pretty slow. Actually, we can see with the red line that if we do only encryption, like SSL would do, we obtain better results. Thanks to the application level, we can encrypt only the objects where SSL must encrypt the entire payload.
So in conclusion, Java RMI is hard to attack because of its complexity. SSL is not very useful in that context, and for better performances, you may at least encrypt the end of packets containing the variables of a program. And SRMI is slow, but it provides access control, integrity, and confidentiality. So I hope you enjoy the presentation, and thanks for your attention.